Hi, my name is Vladimir Horikov, and this is the course about domain-driven design and working with legacy projects. In this module, we will have yet another feature request, this time a more complicated one. It will require us to grow our bounded context into an autonomous bubble by introducing a separate data storage for it. In the previous modules, we implemented the delivery cost estimation functionality. We did a good job. We were able to implement it quickly despite the messy legacy codebase and the database underneath it. The stakeholders are happy with it and they want us to continue. And so we received a new feature request. And now the business wants to be able to create deliveries with more than 4 products. Let's look at our software again. Right now, if you go ahead and edit one of the packages, you will see that there is room for only 4 different products. And if you need to add more, you will have to create 2 separate deliveries for the same customer and distribute the product lines between them, which is very inconvenient to say the least. And it's understandable that the stakeholders want to improve this functionality. And so here we are with this new task. How could we implement it? This is the legacy database. And these are the 2 tables that store information about deliveries in the system. After looking at them, it becomes clear why the application UI was designed this way and doesn't allow for specifying more products. It's because the tables are not normalized. All 4 products are hard-coded into the delivery table's structure with these columns. Instead of extracting them into a separate table, the original developers just inlined them into the parent table. Hence these 2 repeating column names, product line 1, product line 1 amount, and so on. As we discussed in the second module, it seems as if the application initially allowed for only 2 product lines to be added to a single delivery, because the main delivery table has room for only 2 products and amounts. And later, when the business asked for the ability to add more, the developers, instead of eliminating this artificial limit, they just extended it by introducing another table with 2 more sets of columns. It could be because the project's codebase was a mess already at that time, and so they decided to conform to the existing architecture instead of refactoring it. Or maybe they felt a time pressure and needed to ship this update quickly with the intention to refactor it later. Regardless of the reason, now we have a suboptimal design decision we need to deal with. So what can we do here? One option we have at hand is to continue down this path and just extend the second delivery table with more columns. In theory, we could introduce up to several dozens or even hundreds of new columns to this table, and that would satisfy the business needs. But of course, that would increase the maintenance costs of this project beyond all reasons. We would need to deal with an enormous amount of duplication, and if we would need to change anything in the structure of the product lines, for example, store a discount for each of the product lines, that would be a disaster. And so we will not go down this path. Obviously, the database structure needs to be updated. Instead of all these columns, we need to have a separate table that would keep the information about the product, its amount, and the delivery it belongs to. But how to do that exactly? We cannot change the database because the existing legacy software depends on it, and we definitely don't want to deal with the legacy codebase. That was the whole point of having an anti-corruption layer with a new domain model. That is where the concept of the synchronizing anti-corruption layer will help us. Let's take a look at our existing bubble context once again. It consists of the new clean domain model and the anti-corruption layer, which we implemented in the form of repositories. The anti-corruption layer does a good job of separating the domain model from the legacy mess, but it has limitations. Right now, we are limited to operating only the data that exists in the legacy bounded context. It means that when we design the bubble domain model, we can only introduce data that already exists in the legacy database. We are restricted by its structure. The bubble context is completely dependent on the parent context. Any new information that doesn't already exist in it must be added to the legacy system somewhere. And in theory, we can add it there, but this approach has its own drawbacks. If we add a new product line table to the legacy database, and use it from the bubble context, it would contribute to the already high technical debt in the legacy system. When it comes to working on legacy projects, you generally don't want to build up upon the existing legacy codebase or the database, because that would inevitably lead to increasing software entropy. This additional table, even if designed and implemented well, would increase the amount of code we would need to deal with when working with the legacy codebase. And it will also introduce additional confusion when trying to make sense of it, because it wouldn't be obvious why there are two tables with information about product lines. So we will not do that. Just as trying to refactor the existing database, adding new tables to it is not the best option. What we can do instead is we can create a separate data storage for this information and synchronize it with the legacy one. Here's how it will look. The new data storage will hold all information our bubble context needs. That means the bubble will become independent from the legacy database. It will now retrieve all required information from its own data store. The bubble will become autonomous. Because of that, it shouldn't reside inside the legacy project anymore. That's why I'm depicting it as a separate independent component. And just as any other independent piece of software, it will have its own database. We will need to upgrade the anti-corruption layer too. It will need to synchronize the old database with the new one, not merely query the old database as it does now. Hence the name synchronizing anti-corruption layer. Because the anti-corruption layer will significantly increase in scope, it would be a good idea to treat it as a separate bounded context from now on. It will also become a completely independent piece of software. We will discuss how exactly the anti-corruption layer will do that in the next module. You can view this new bounded context as the next step from the bubble. It is now autonomous bubble as we're cutting the connection to all the legacy data. This autonomy will help us moving forward because we will not be limited to the legacy database anymore. You can say that it is more scalable. We are also preventing the legacy ball of mud from growing as we don't introduce new tables to its database. Alright, I created a new database behind the scenes. This is its script. Use it to create your own copy of it. You can find it in the course's exercise files or on GitHub in this modules folder, named syncACL. You don't need to read it. I am opening it to just show that there is a bulk of SQL statements in here. You can run them in SQL Management Studio. And let's now look at the database more closely. First of all, look at its name. I entitled it Package Delivery New to match the name with the name of the bubble bounded context. It's always a good idea to name databases after your bounded contexts to avoid any misconceptions. It has three tables in it: delivery, product, and product line. Here they are on a diagram. Let's compare it to the legacy database's structure. The first thing you might notice here is that the names of these tables and columns in them are not weird, which is a big plus to the readability. Next, just as with the bubble domain model, here we also bring in only the data we use. Note that there is no customer table in here. And the product table contains only a single column with the weight of the product. And by the way, this single column is named weight in pounds to avoid any potential confusion about units of mass we are using. Note that there is no separate table for address either. All its fields are inlined into the delivery table. You can see here destination street, city, state, and zip code. That's because the concept of address in our domain model is a value object and has a one-to-one relationship with the parent delivery entity, meaning that there can be only one address for a single delivery. The best way to handle data for such a value object is to inline it into the entities table. You can learn more about it in my Domain-Driven Design in Practice course or in this article. In short, there is a nice mental model you can adopt in order to understand why we're inlining this data. You can think of such value objects the same way you think of numbers. You wouldn't create a separate table for cost estimate, right? Although in theory you could. You could introduce something like cost estimate table with an ID, a value, and a delivery ID. But it doesn't make any sense because it's just a single value. You don't need to keep track of it, and if it changes, you just replace the number with a new one. You don't need to preserve the identity of that specific number. The same is true for these fields. They too represent a value with no identity, a value object. The only difference here is that this value spans across multiple columns. Alright, and note also that I used a prefix named destination for each of the address fields. This actually differs from the name of the property in the delivery entity, so let me change it. Here it is. Renaming it to destination. Also renaming the related variables. Here it offers to modify some of the texts, but we won't do that. Good. Let's get back to the database. Of course, the city and state portions are separated in the new database. There is no need to keep them merged together in this column. All tables now have proper foreign key constraints, which is a great thing as it allows you to avoid data inconsistencies, such as when a row in one table refers to a row in another by its ID, but that second row no longer exists. Having foreign key constraints prevents such situations from happening. And by the way, notice that the IDs themselves don't have an identity specification. That is done for a reason. We don't allow the database to automatically set IDs for deliveries or products. We need those IDs to match what we have in the legacy database. The only exception here is product line. In it, we do allow for automatic identity assignment because there is no corresponding table in the other database. We have full control over it. Note that I changed the columns data types too. No fixed size strings anymore, only nvarchar. And instead of float, the cost estimate is represented with a decimal, which is a more appropriate data type for a money field. And finally, the nullability of the columns reflects the preconditions of the domain model. For example, delivery should have a destination, and all fields in the address value object itself are not nullable. Thus, the fields related to the destination address in the delivery table are marked as non-nullable too. The weight of the product should be specified as well, hence no nulls in this column either. Alright, here it is, a brand new database for our bubble context. Note that as you start everything from scratch, it's a good idea to follow database delivery best practices right off the bat. Put the database to the source control and implement a migration-based approach to keep track of any changes in its schema or reference data. Refer to my other course to learn more about it. Now that our bubble context has its own database, we need to adjust the persistence logic. We will also modify the domain model itself. We need to introduce more information to it in order to handle the new requirement independently from the legacy database. For example, right now, the delivery class doesn't reference the product lines because they are provided by the legacy UI. This will not be possible anymore as that UI simply cannot handle more than 4 product lines. So we will have to build a new UI window and a view model for that purpose. We will talk about the UI and a new entry point for the autonomous bubble shortly. For now, let's focus on the persistence component. We currently have 2 repositories. They are both part of the anti-corruption layer that retrieves data from the legacy data storage. With the autonomous bubble, we won't need them anymore. Our bubble will no longer know how to convert the legacy data. That is going to be the responsibility of a new synchronizing anti-corruption layer, which we'll introduce later in this module. Instead, let's add new repositories that work with a new database. Because these new repositories don't work with the legacy data, we will put them to the deliveries folder, along with the domain model classes. The first one is going to be the delivery repository. Changing it up. Good. Note that as the database structure is robust and straightforward, we can use an ORM here. There is no need in handcrafted SQL anymore. The mapping between the domain model and the database is going to be simple and smooth. But because the use of ORMs is not the primary goal of this course, I'll skip them and will continue with Dapper. The scope of our project is not too large anyway, so there is not going to be that big of a difference in terms of the amount of code here. But keep in mind that your project is most likely larger than this, and so the use of fully fledged ORM, such as an Hibernate or Entity Framework, would be justified in your case. Alright, first of all, let's introduce some data classes. These are the classes that reflect the shape of the underlying database. This one is for the delivery table. Along with the data from the delivery table, we will also need information about product lines. Here's a class for it too. Note that we are combining both tables into one, no need to have a separate class for the product one. The main API here would be the getById method. It will accept the ID and return a delivery. Inside, we will retrieve the raw data first, and then map it into a delivery object. So the algorithm is pretty much the same as with the older repositories. The difference here is that the source data comes from our own native data storage. Okay, the first method is getRawData. It will accept an integer ID and return both a delivery and a list of product lines in it. I'm using the new C#7 syntax for returning a value tuple, creating a new SQL connection, and here's the SQL query. Note how clean it is, no weird names or joins. The first select statement retrieves data from the delivery table, and the second statement combines data from both the product line and product tables. The SQL returns two result sets, so we need a special Dapper functionality for that, query multiple. It returns a reader, which we then use to read the results one by one. The first result is the delivery data, and the second is a list of product lines. Returning both, good. Note that Dapper handles all the mappings between the properties in the data classes and the data from SQL. We don't need to worry about that. Alright, using that method to get the raw data and mapping it to a delivery instance. Creating the method. Good. Now with all this data, we can instantiate a delivery object. Passing the ID, the address, it will consist of the destination street, and 3 other parameters. Let me clean it up. Perfect. At this point, we need to extend the delivery class. As you can see here, it only contains the information about the destination address. As I mentioned earlier, that's because the current implementation of the bubble doesn't need to store the product lines. The legacy code passes them to the bubble. And it also doesn't need to keep the estimation cost because the bubble returns this estimate to the legacy context and it then saves it on its own. But because we won't have this tight integration with the legacy UI anymore, we will need to keep all this information in our domain model. So let's add a list of products to be delivered and an estimate. I'm using ReSharper to initialize these properties from the constructor. Good. And let me also put a couple more preconditions here to make sure the entity is always valid. The cost estimate should not be negative, and the collection should not be null. Now we can pass the estimate to the constructor. As for the lines, we need to first convert them from the lines data. So for each line data, instantiating a new product line, the product, and the amount. Saving to a local variable, using the delivery constructor, and returning the delivery. It looks good, but we're not done yet actually. As you can see here, the product line table also contains an ID, and we will need this ID in our bubble context too. We will use it to match the product lines in our domain model with the product lines already existing in the database, to see which of the lines are new, deleted, modified, or unchanged. And because of that, we will need to treat the product line domain class not as a value object, but as an entity, in order to be able to assign an identity to it. It's easier to deal with value objects instead of entities, and so it's unfortunate that we need to do such a modification to our domain model. But you will need to make trade-offs like this one from time to time. They are inevitable. We just will not be able to easily differentiate between product lines if we don't keep their IDs. In our case, the trade-off is between the domain model purity and the simplicity of the persistence layer. So, replacing the value object base class with entity, I need to accept an ID in the constructor and pass it to the base one, adding a new precondition, and removing the getEqualityComponents method. Unlike value object, the base entity class handles the equality by comparing the ID of the entity, not its components. Now I can pass the ID to the product line class. Good, the delivery repository is ready. Let's create a product repository real quick. Creating a class. Good. So here is the product data with the ID and the weight in pounds, a getRawData method, a method that converts this data to a product instance. The public getById method will call both of them one by one. Good. And because we now use the new database, we also need to pass the new connection string to the bubble context. So let's rename this one to legacy database connection string and introduce a new one, bubble database connection string. It will target the package delivery new database, because remember, this is how we entitled the new database. The new connection string will go to the settings class, which is part of the bubble. And just to show you the difference between them, the DB helper class is part of the legacy codebase. Here it is. Let's recap what we did in the previous two demos. We've promoted the bubble context and made it autonomous. The bubble now has its own data that is stored in the native format. In other words, we don't need to make convoluted translations between the data storage and the domain model. The mapping is simple and straightforward. Our bubble context has grown up as we've cut all connections to the legacy data. When creating the database, we followed the same guideline we discussed in the previous module. We designed it as if there was no legacy database whatsoever. The database structure is clean and follows all the best practices, like for example having foreign key constraints. We didn't allow the legacy codebase influence our design decisions. Note that although we used plain SQL to retrieve data from the database with the help of Dapper, it is now possible to employ a fully fledged ORM, like in Hibernate or Entity Framework. And if your project is more or less complex, you would probably want to do that, because such an ORM will save you a lot of time that you will not have to spend writing custom SQL queries. Another benefit here is that you can now test the new codebase without any mocks or other test doubles. It is possible to write integration tests that involve the new database without touching the legacy system. We introduced the new versions of the delivery and product repositories. Unlike the old versions that comprised the anti-corruption layer, the new ones are not part of that layer anymore, as they work with the Bubbles database instead of the legacy one. We still have the remnants of the old anti-corruption layer in the Bubble, the old delivery and product repositories, but we will soon move them into a separate bounded context, a synchronizing anti-corruption layer that would not be part of the Bubble anymore. After that, our Bubble will not know anything about the anti-corruption layer. We also updated the domain model to include data that we didn't have to include previously, the delivery cost estimate and the collection of product lines. All in all, the presence of its own data has made the Bubble more scalable. It's now much easier to scale and evolve it, as we are free to introduce data that is not present in the legacy system. Note that upgrading the Bubble to an autonomous Bubble is quite a large leap. The separate database means that the Bubble's maintenance cost will increase significantly. But if you have long-term plans for this project, the leap is worth it. It's an investment that will pay off in the long run. Now that we have the new domain model and a separate storage for it, it's time to think about the user interface. Look at the existing UI window again. It has space for only 4 different products, and we will not be able to reuse it because of that. Even if we add several more lines here, this design is fundamentally flawed, as the number of product lines is fixed. What we need to do instead is allow the user to come up with as many or as few lines as they want. We can add some technical limitation, for example, set the maximum number of lines to 100, but we shouldn't have to list all those 100 items up front on the UI. So we will create a separate window for our new functionality, and that is going to be a new entry point for our bubble context. Which is good news, as we will be able to decouple our codebase from the legacy system even more. Previously, we had to inject the bubble into this window and call it from the legacy view model. Now we will have our own UI code working with the bubble. As we discussed earlier, we cannot have a separate executable with our own UI for the bubble, and so we will still need to incorporate it into the legacy application. But it's not going to be a lot of work either. What we'll do here is we will add a new edit package window alongside this one. The main window then will have another button that will show up this new window. When it comes to anything that relates to the bubble context, it's a good idea to keep it as isolated from the legacy as possible. So we will create a new folder in the UI project that would contain our new user interface. I'm calling it Delivery New to match our naming convention. Alright, the details of developing WPF interfaces is not the primary goal of this course, so I will not bother you showing the XAML files. Here I added a XAML view for editing a package off-screen. I also created a stub view model class that would glue our domain model and the view together. It already contains all the orchestration. For example, here is the delivery domain object the view model will represent. It will display its product lines and the cost estimate. And here are the commands that correspond to the buttons on the UI. The user will be able to add a new product line, delete the existing one, and recalculate the estimated cost. What we need to do is we need to fill out the gaps in the logic. I'll show you how this stub looks, but before that, we need to fix the compilation errors that we introduced after refactoring the domain model. The first one is in the delivery repository. This repository is part of the old anti-corruption layer that we used before making our bubble autonomous. The error is due to the fact that we added 2 more parameters to the deliveries constructor. We won't be using this class anymore, as we will introduce a new version of the anti-corruption layer soon, so let me comment this line out and return null instead. The second issue is in the estimate calculator class that the legacy UI called in order to get the estimate. We won't use this class either, because we will have a brand new UI window for this functionality that will work with the delivery domain object directly, so I'll comment out this code as well and replace it with returning 0. If we run the application, edit this package, and recalculate its cost, you can see that it turns to 0 due to our changes. Note that it might be a requirement for you to keep the functionality of the old UI intact. In this case, you will need to maintain the old anti-corruption layer and keep it functioning. This is rarely the case, though, because what's the point in investing into this activity if we have a new, better UI for the same task? So we won't do that. And here's the new UI itself. It's a stub and doesn't exhibit any functionality yet, but it's still helpful to see what the interface will look like before starting coding it. This text box will display the cost estimate, and this grid will list all the product lines in the delivery. Alright, we can now start filling the gaps. First of all, we need to instantiate an address resolver, a delivery repository, and get the delivery to work with by its ID. And next, we will handle the recalculation functionality. Here's the method that will be responsible for that. In it, we need to first check that there are some product lines selected. After that, we'll use the address resolver to locate the distance between our warehouse and the destination address. If the return distance is null, this means the destination address the user specified is not found. Finally, we can calculate the delivery cost. Here we already have the method that does it for us, but we will need to modify it. It was written with the assumption that the delivery class doesn't store neither the cost estimate nor the list of products, and so this method accepts this list as an input parameter and returns the estimate as a resulting value. What we need to do instead now is we need to remove the parameter and replace it with a property. We don't need this part of the contract anymore because we've got rid of this limitation. Our packages will now be able to have more than 4 products. Changing the text and this last bit. Good. Aside from getting rid of this parameter, we also don't need to return the cost estimate. Instead, we can update the cost estimate property like this. And of course, we need to introduce a setter for this property in order to be able to do that. And let me also rename this method. It doesn't return anything anymore, so I'm calling it Recalculate Cost Estimate instead of Get Estimate. I can now use it in the view model, like this. And I also need to notify the UI that the cost estimate property has changed, so that it refreshes the text box. Let's start the application once again. This method will be called after we click the Recalculate button. For now, we don't have any product lines, hence this error message. The other 2 buttons on this UI screen are adding a new line and deleting an existing one. Let's implement the corresponding commands for them. The first one for adding a product line, and the second one for deleting it. If you wonder what this link expression is about, that's for determining when to enable the button. This expression means that the delete button will only be enabled when the user selects a line in the grid. The input parameter here is of type product line because the grid's data source is a list of product lines. Here it is, the data source. Alright, to delete the line, we need to create a corresponding method in the delivery class, deleteLine. I'm using ReSharper to generate a method for me. OK. Currently, the lines are represented as a read-only collection, so we need to introduce a private backend field with a collection that we can modify along with the property for the public consumption. Here it is. The property will now act as a proxy on top of this field. In the constructor, we need to assign the list of lines to the field instead of the property, and to delete a line, we can use the remove method on the mutable list of lines. Good. After removing the line, we need to also notify the UI about the change in the list of products. Let me run the application. There is nothing to delete yet, so I cannot show you the deletion functionality. But you can see that the button is now disabled. That's because we need to select a line in the list in order for it to become active. Note that the grid contains a name column. That's the name of the product, and it makes sense to display it along with its weight and the amount the user has ordered. But if you look at the product domain class, we didn't include this field to our domain model initially. Now it is clear that we do need the product name, so let's add it here. The property itself, and initialize it from the constructor. It's also a good idea to mention it in the contracts. All products must have a non-null name. Now let's change the product repository, modifying the product data class that represents our data model, and passing the new field as a parameter to the constructor. Note that we don't need to do anything else here, because our select statement retrieves all the fields from the product table, and Dapper does the matching between those fields and these properties automatically for us. There are a couple more compilation errors left. The first one is in the product repository. This is also a part of the old anti-corruption layer. We won't be using it anymore, so I'm commenting this code and returning null instead of the product itself. The second error is in the delivery repository. Here we also need to select a product name when we query the delivery with its products from the database. So I'm adding a product name here and here in the SQL query. By the way, we have an error in this query. It should be p.productID, not l.productID. Now we can pass the product name to the constructor. Very good. Let me close all these tabs and return to the view model. Let's test what we have so far. For that, let's manually add a product line into the database. Any product would suffice here. Running the application. Very good, here it is in the data grid. And we can even delete it from here. Of course, we haven't yet implemented the save functionality, so the change will not be persisted in the database. If I reopen this package again, you can see that the best pizza ever is still there. We can also recalculate the delivery cost estimate. Very good. Let's now implement the addition of new product lines. That is going to be another window with its own view model, Add Product Line View Model. It will allow us to select a product and specify the amount. Let me run the application. It will look like this part of the old UI, the product itself and the amount. The difference would be that we will only allow for selection of one product. Another window will be responsible for choosing a product among all products in the database. It will open after clicking the Change button. Alright, just as before, I'm adding XAML views and stub view models for these two windows off screen. Here's one for adding a product. Here you can see it has the product and the amount properties, which we can use after showing the window to the user. So, if the dialog result is true, meaning that the user has clicked the OK button, then we will add a line to the delivery and update the UI. If we run the application, here's how it looks on the interface. The two fields, just as in the old UI window. This window doesn't have any functionality yet, so let's implement it. The OK button will close the window by setting the dialog result to true. The canSave method will indicate when the OK button is enabled, when there is some product selected, and when the amount is greater than 0. The Cancel button will just close the window without checking anything, and the Change button will allow us to choose the product. Here I also instantiate a new view model. This one will show all products in the database. Here is the field that the UI will bind to. And here is the selected product. To show all products, we need to add a new method to our repository, getAll. It will assign them to this list. Generating the method, and here is its content. As you can see, it selects all products from the database and maps them to the product domain class. The OK command will close the window with the precondition that some product is selected by the user. This product will automatically be saved to this property. This is done by the XAML binding. The Cancel button will also close the window, but without indicating a success. Very good, we can now show this window to the user, and if they click OK, record the selected product into the property field and notify the UI about the change. Finally, we can add a product to the delivery. For that, we will introduce a new method in the delivery class. Generating it, changing the names of the parameters, and adding a new line to the line collection. The ID is gonna be 0 because there is no such line in the database yet. Running the application, let's select a fridge in the number of 3 items. Good, you can see the fridges have appeared in the list. We can also recalculate the cost, and the text box will show us the correct cost estimate. Finally, we can delete the pizza. Very good, everything works as intended. Everything except saving the delivery to the database. Let's fix that. We have 2 buttons left to implement on our new user interface, OK and Cancel. So let's go back to the view model. Here are the commands for these buttons again. ReSharper marks them as none used. The Cancel button will not do anything aside from closing the window. As for the OK one, it needs to save the delivery package to the database. For that, we will be introducing a new method in the repository. Let me generate it, move it up. OK. Here we also create a new connection and execute this query first with these parameters. What this query does is it updates the delivery table with the new cost estimate and deletes all the product lines belonging to that delivery. This is the database schema. We are updating this field and removing product lines from this table. After all product lines are cleaned up, we are recreating them with this query. Here is the execution of it. Let me move all these parameters to separate lines. Good. Note that we are passing a collection of objects with this SQL statement, not just a single object. Dapper will iterate through this collection for us and run the query for each of them. Pretty handy. Let's launch the application and see how it works. Adding a couple of fridges, deleting the pizza, and recalculating the delivery cost. Reopening the package. Very good, you can see that all the changes have been successfully persisted. 2 new fridges, the pizza, and new delivery cost. Alright, let's quickly fix a small issue with our code. As you can see on this diagram, the cost estimate is actually nullable, whereas if you look at our data model, it is marked as non-nullable. And the same is in the domain model. Let's bring them to consistency, changing the cost estimates type to nullable decimal, and doing the same in the delivery domain class. We need to adjust the view model. If the cost estimate is null, we are showing 0. Very good. And let's also look at how we deal with product lines. We are not actually using the product line ID here. We only operate the product ID, the amount, and the delivery ID. Here these fields are on the database diagram. The product line ID is managed by the database itself. It auto-assigns a value to it on each product line insertion. The reason why we are able to disregard the product line ID in our codebase is because of our approach to persisting them. We just delete all the product lines in a given delivery and recreate them from scratch. We could do matching instead when we determine which lines are new, which are deleted, and which are unchanged. And that could potentially bring some performance benefits because we would be able to reduce the number of SQL queries needed to update the delivery. But that would complicate the code. In most enterprise-level applications, performance is not that big of a concern to introduce such a complication, and so it's a good idea to aim at code clarity and simplicity first, and only after that target performance. There is another benefit to this approach. As we don't need to deal with the product line ID, we can actually drop it from our domain model. Remember when we first defined the new domain model for the autonomous bubble, we had to turn the product line class from a value object to an entity in order to be able to keep track of its identity. Now we don't need to do that anymore. Its identifier is irrelevant for us. And so we can turn it back to a value object, which is great news because one of the most important guidelines in domain modeling is that you need to prefer value objects over entities. So let's refactor the product line class once again, changing the base class to value object of product line, implementing missing members, removing the ID, we don't need it anymore, and in the get equality members, return the product and the amount. Very good. Keep in mind that the process of domain modeling is highly iterative. There are a lot of new insights and trade-offs you need to make along the way. And sometimes, during refactoring, you will come full circle to a design decision you had at the beginning. You shouldn't view this activity as wasteful. It's a learning process, and you gain a lot of domain expertise as a result of it. I'm showing you the full picture of such a modeling and not just the end result to give you an example of how this process might look. Alright, we've introduced some compilation errors. Let's fix them. In the delivery class, I can now get rid of this 0. And in the delivery repository, we don't need to pass the product line ID to the constructor either. Let me remove it from the product line data and from here as well. Let's verify that we didn't break anything. Adding our pizza back, a TV set, in the number of 3 items, deleting the fridge, and saving it. Very good, you can see that everything works as before. In the last 3 demos, we implemented a new user interface for our autonomous bubble context. Just as the old database couldn't handle the new requirement, the old interface couldn't accommodate our needs either. It had place for only 4 product lines, and so we had to come up with a new window in order to be able to add an unlimited number of product lines to a delivery. And we did it. The new interface perfectly fits our needs. It allows for both estimated cost calculation, which was the first requirement on this project, and addition of any number of product lines. The introduction of new user interface is quite a lot of work, but at the same time it's easy to work with. That's because it's perfectly lined up with the boundaries of our bubble context. Now all the layers of the bubble are brought together. The database, the domain model, and the UI all work within the same bounded context. Except for the small amount of code we needed to inject the new UI into the legacy application, the bubble has no connection to the old codebase whatsoever. The separation between the old and the new codebases has become more explicit. It's important to maintain this separation. Don't allow the bubble to query data directly from the legacy database. It would quickly lead to erosion. It would damage the new codebase. Any new data the bubble needs should be added to its database first. Because the domain model and the database are now perfectly aligned together, we are able to use a fully fledged ORM here, like in Hibernate or Entity Framework. There is no need in manually written SQL queries anymore. Note that we didn't remove the old window, but rather we now have both the old and the new windows working on the same functionality. You typically don't want to do that though. The whole point of writing the new interface is to replace the old one with it. We will keep the old window for illustration purposes, to show how the data is synchronized from the new database to the old one in the next module. Also note that while we didn't use a lot of value objects in our new domain model, in a larger and more complex system, we definitely would. For example, we could introduce a dollars value object to represent the cost estimate, which currently is of type decimal. Or we could introduce a separate type for the concept of product weight. We could call it pounds, which would eliminate any misconceptions about the unit of mass we are using to measure the weights of the products. Overall, getting rid of primitive obsession is a good thing, but there's not much benefit in doing so in our particular situation, aside from increased readability, so we will not do that. Should the situation change, however, for example, should we need some additional logic associated with the delivery cost or the product weight, we would definitely add those value objects to our domain model. If you want to learn more about primitive obsession and how to get rid of it, check out my course about functional programming here on Pluralsight. In this module, we dealt with the new business requirement, adding more than 4 product lines into a single delivery. We couldn't implement it using the existing database, because it only allowed us to introduce maximum 4 lines to a package, and so the strategy we employed in the previous modules wouldn't be enough here. The old bubble could only work with the data that exists in the legacy database, and it could only do that in a way that is translatable back. So we had to grow our bubble into an autonomous bubble by cutting all connections to the legacy system. We introduced a separate database for that autonomous bubble. We also defined a new user interface for it. The new bounded context now has the full vertical slice of functionality, from the UI to the database. Cutting the connection to the legacy system means that we removed the anti-corruption layer from the boundaries of the bubble context. Well, technically it's still there, at least the remnants of it. But we will soon transform it into a bounded context of its own. It will synchronize the old and the new databases. While previously it was only the legacy system who was unaware of the anti-corruption layer, now both the bubble and the legacy system will not know anything about it. When creating the database, just as with creating the domain model, we didn't allow the legacy system to influence our design decisions. We implemented the system as if it was a greenfield project, only looking at the requirements we had at hand. We didn't introduce any data we didn't need to implement the new requirement. While working on the new functionality, we built upon the domain model from the previous modules. We modified it several times until we came up with a satisfactory solution. Note that while doing so, we came full circle with the product line class. It started as a value object, which we then converted to an entity, only to convert it back to a value object when we realized that we don't need to handle its identifiers. It's not uncommon to have your design decisions reverted. View it as a natural part of the process of domain modeling. In the next module, we will talk about the anti-corruption layer. We will promote it to a separate bounded context that would synchronize the legacy database with the new one.